right, so we've got a smart contract. We got this shell. We have a total supply. We've got a name, symbol. Amazing. It's got 1 million tokens. That's so awesome. But hold on. What can we actually do with this smart contract? What can people do with this contract? And unfortunately, right now, the answer is not a whole lot. In fact, you can't really do anything with this because there is no functionality written for it yet, right? All we have so far is just some static. We've got some variables here, some strings, which are set. And so there's information, and we've taken that information and put it up on the blockchain. We have not provided any real functionality. So we want to be able to add some basic functionality for our tether. We want people to be able to transfer it, right? We want people to be able to send tether to other people, receive tether, and we also want to be able to, do this in a secure fashion by making sure that people approve these transactions. So these are some two very fundamental, important functionality that we're going to now together code in for our tether contract. And we do this in Solidity, explicitly as always by setting up events and then explicitly stating these events and then setting them to some functions in which we can customize the functionality of these events. And what do I mean by events? Well, I'm going to show you now. So we're going to have two events. Can you guess the names? Well, the two things we were talking about, of course, was the event for transfer. So we're going to have a function transfer, and we're going to set it as an event so that we can emit it in our functions. And then we're going to have another event as well, which will be to approve these transfers. Okay. All right. And let's add some semicolons for Solidity. Now, what's the key information we want to add in our transfer here? What do you think it could be? Well, we want address, right? And that address has to be from somebody. We want another address, which will be to somebody. We also want to have a uint, which will be value, essentially. So we're going to have our integer as a value. So we're going to put, I'm going to add. And these addresses are going to be indexed. And if you don't, well, when we add indexed, essentially this allows us to filter through the addresses so that we can search for them. So we get this parameter where we can index like that. And what do you think? Okay. And so now that we've created our transfer parameters, what do you think we should be putting in for our approval? Well, it would be very similar, right? We're going to need addresses. We're going to need addresses and a value. The only difference here is that we're going to change from to the owner, right? Because the approval will always be from the owner to a spender, right? Because approval always has to come from the owner. We can be transferring from wherever, but approval has to come from the owner. Okay, and now we're going to use some mapping in order to keep track of the balance for when we're transferring, when we're updating. It's very important to have that. And so we're going to go with mapping over here. We're going to write address, public, and we're going to define balance of. All right, and now we can create a constructor. So we have our special constructor function. And Solidity, let's add our semicolon over here. And what are we going to add into our constructor? Well, we're going to put in the balance of. The balance of what? Well, the balance of the person currently with a contract, so message.sender, if you remember. And what are we going to set this equal to? So what should the balance be, right? What should the balance be set to? Well, we need to set this to our total supply. And if you got that right, that's awesome. So you understand that that is basically our supply of how many tokens that we have in our tether, and by doing that we are able to do transfers and approve to do transfers to and from and keep track of the balance in our contract. And if you didn't really understand that so far, don't worry. Once we have the full functionality of this contract written out, we're going to run some more tests on the Truffle console, and I'm going to show you how we can access the balance together. Okay, so let's create our transfer function. Now that we have our event set up and we have our balance of map ready to go, and as well we've set our balance to the total supply, let's write out the actual logic for this function transfer. So we're going to create a function here called transfer. And it's going to take 2 arguments, 2 and value. And what type of arguments do you think these are? Well, 2, that is going to be a address, right? And value, if it's a value, then it's likely a integer, right? Unit of measurement. So we have our uint, and we're going to make it public. And we're going to create a bool. Create a public returns. We're going to do a bool success. Bool success. Oops, not return, returns. Bool success. Okay. And we're going to write balance of message.sender equals the balance of message.sender minus the value. And actually a better way to write that would just be minus equals the value. Okay, and what does this mean? Well, basically whatever the balance is from the message sender, whatever our balance is going to be that same balance when we make a transfer minus the value, the amount we're transferring, which makes sense, right? When we make transfers, when our customer makes a transfer, or whenever anyone is making a transfer from this token, we don't want to be adding to the token. We want to be subtracting that amount, right? And the amount is the amount that you have minus the amount that you want to transfer. Okay, so now that we see the logic for taking out from our balance, what about adding that balance to somewhere else? How would we write that balance? You can go ahead and give it a shot. Pause the video and try to write out the logic, because the more that you try to write stuff out too, and you don't just copy what I'm doing, the better you're going to get at figuring this stuff out. That's taking it to the next level, and I always encourage you to go ahead and stop and try things on your own. Try them for yourself. Stop the video before I do something and see if you can do it first. Okay, so let's give it a shot. So balance of, what do we put in here? It's not the message sender, right? We're going to use our 2, so our value, okay? And what are we going to do with this value? Well, we're actually going to increase plus equals underscore to our value. And now we're going to use the emit. We can run transfer, and we get our from to value. And the final thing we want to do here is return the function as Boolean successful. So we're going to return as true. All right, so we have effectively written out the transfer function together, and hopefully you understand what all of these, hopefully you understand what the logic is here, and you're not just copying this down, right? It's the balance of the message sender. So the balance of coming from the message sender is going to be subtracted from the total value, right? This is when we're going to be transferring it. Now, what happens to the person receiving? Well, they're going to get the plus end of the value. So that contract address, or not person, but contract address gets the plus. So that's the 2, and that's the message sender, us, or the contract when I say us, all right? Like coming in from the Tether contract. And then we run our emit transfer, okay, which has our address indexed from to and our value, okay? So we run our from to value and we return it as true. And a final thing that we should actually do here is we should create a condition and make sure that what we're sending is always greater or equal than to the value, right? We don't want to be transferring if it's less than the value. So we have to run a require here. We can say balance of g.sender should be greater than or equal to. Okay, and let's add in some comments so we understand what's happening here. So require that the value is greater equal for transfer, right? Transfer the amount and subtract the balance. Add the balance to transferee, or add the balance, we run the transfer, and we return it true. Okay, so this is our transfer function. Now, the next function let's do together is going to be the, let's just stop there for a second because this is getting quite long, but in the next video we're going to figure out the transfer from function as well as the approve function together for our smart contract. And that's it. Then we've actually created together our functional smart contract, which we can transfer to, from, and give the additional security for approval as well. Great work. I'll see you in the next video.
All right, so we are deep in the middle of the final project here, and we're building out these tokens, and we're working with events. So I just want to be clear. Here. And what I want to do is, as we go through these sections, I know there's a lot of concepts being thrown around, things that we could have already gone over before, but now, we're kind of going through it quickly. So I want to make a few clarification videos to help you. So it's up to you if you want to watch these or just keep moving ahead. But each one's going to have a specific topic that we try to clarify for where we are. Right now, this one's going to be about events, because we're talking about events. And I know I'm writing out these events, and we've looked at it before. But just in case you're a little bit unsure and you're saying, well, okay, we're making these events, but what really are events in Solidity, and how is it relevant to what we're doing right now? And it could be confusing you with the functions. Because you have to remember, the events are not actually the functions of the events, right? The events are just events that we emit to the outside world to let our consumers know about what is going on. So the transfer events and these things. So let's just go through it together. And again, there's going to be a bunch of these. You'll see me with a lot of ES6 arrows, anonymous function arrows. You don't know what that is? I'll make a video on that, and other things as well. So let's start with this one to get the ball rolling. Let's get this ball rolling. All right. So let's start with let's just start with events. So what are events? Well, let's pretend, all right, to help you understand better what events really are in Solidity, let's pretend that we have a decentralized exchange. All right. So if we had a decentralized exchange, if we were building a decentralized exchange app, then on the smart contract, right, the traders, they can trade tokens. But what we want to do is we want to emit events so that the traders can get the data, so that our front mobile applications get the data. They can see the events. They can see what is going on. And this can only happen outside. These events don't get stored in Solidity. We can't access it afterwards. The only people who can access it are the people outside, okay? And so it's a one-way transmission, and it's got lower gas costs, all right? And after you emit these events, you can't read them in the past, all right? Only for entities outside of the blockchain. Not stored as memory. It's not stored as memory. And that's why they have lower gas costs, all right? So hopefully that helps to clarify. But let's take it even further. Let's write out the events and actually look at it to help you really understand what's going on with events. So I have this contract. You don't have to code along. You can if you want, if it helps you. So let's say we have this contract, learn events, right? So I want to make an event. So how do we actually make events? There's two steps. So the first thing we want to do is, one, we want to declare the event, and two, we want to emit the event. All right. And I realize it's the typing could have gone the way. So one, declare the event, and two, we want to emit the event. That's how you make events. All right. It's a two-step process. All right, so let's first declare an event, and we can call the event what we want, whatever we want, So we do it by bringing an event, right? Just like when we want to declare anything in Solidity, we're declaring an event, right? And this is like a data type, right? So we're bringing this event, And so we've been making in our project these send events, transfer events, so we can be specific. But let's say for this decentralized exchange, we want to make a new trade, right? An event called new trade. So we would make an event and we call it new trade. Nope, new trade, okay? And then we bring in the parentheses. And then what we put inside our arguments, they're the parameters that are going to set up this event. So what's important? What do we want to emit? What are the valuable things? Well, if it's a trade, things that could be important is the date to start with, right? So that we can emit the date for when the trade happened. And so the date would be what? Well, the date would be a number, right? So we'll say uint, and we're going to say date, all right? What else is important? Well, the addresses, right? Like the address of the trades. From where is this trade coming from and where is it going? So we can create an address from, all right, and an address to. And then what else would be important? Well, the amount, right? If we're doing a trade, they want to see what the amount is. So let's make an amount, all right? This is all it takes to declare the event, all right? We declare the event. Now, what if we want to emit the event, all right? What if we have a function where we make the trade? So we want to put the event in that function, right? Because when we make the trade, that's when we want to emit the event. That's when the trade is actually happening. That's why the trade would go into a function called trade, right? Transfer would go into a function called transfer, and transfer from. Send would go to a send. Sent would go to a sent, right? So that's why we would put the trade in a trade function. So to the emit into a trade function. So what we want to do is create a function, all right? And this, let's say this is our trade function, right? So what would our trade function take as arguments? Well, we would put an address to, right? Because it's a trade. And then what else do we want to say? Well, the amount, right? So uint amount. And since it's a trade, this doesn't have to be public. We're going to make it external. All right, we're starting to practice better visibility mechanisms and making everything public. That's a big no-no. So we just do this external. All right, and now in the trade, we can have the functionality for our trade plus what? Plus what? Plus the emit of the event, right? This is where we want to emit the event. So how do we emit events? The second part of this. How do we emit the event? Well, in order to emit the event, we just say, all right, now it's time to emit, just like that. And previously, if you end up working with older Solidity projects, you're going to see that actually emit. You didn't have to actually write emit. So if you see just the event being brought in, don't get confused, all right? Don't get confused. It's just because the emit isn't there. So that's just a heads up. So we would say emit new trade. And now we could hook up the trade to our arguments, right? So what do we want to emit in our new trade? Well, the date, that's the first one. So how can we bring in the date? How can we set this up? Well, we could actually use one of Solidity's global variables, which actually shows you the timestamp. And all you need to do is just type in block.timestamp. All right, so that's the date. Well, since it's a trade, now we can actually put our addresses, right? We want the to, where it's going, and the amount, right? So we want to have to, and we want the amount. This is what we want to emit, right? This is what we want to emit. And it's also important to note, something else I want to note, when you're writing the names of your events, you should always have camel case in the beginning. You should always do a capital letters. So camel case is a good convention, something to remember. All right. Now, how does this actually set up? How do people actually see this event? Well, we would do that with a library, Web3.js, and we're actually going to do it in the course. So I'm going to show you how this actually works. We're not going to do it now, but an outside consumer can't see the event through Web3. All right, Web3.js. All right, and also just so you know, block.timestamp is a global variable, special variable that gives the current gives the current timestamp. All right. All right, so hopefully now this makes sense. Hopefully this makes more sense in case you had some confusion with events. The final thought I'll leave you with also, something that could actually help you further clarify, I know we already talked about in the course, is the indexes. So what are these indexes? Well, we can add these keywords indexed, and the thing is, what index does, it allows the outside consumer to filter through and find, let's say, filter out and get the information that they need. All right, but when we do this indexed, it's going to cost higher gas, right? This is going to cost Ethereum higher because then they got to add the index to it. So you're only allowed, you can only use 3 indexes. That's all you're permitted to use per event, all right? You want to be events. So you want to choose here what's important. So we're going to say index the date, and then index, let's say 2, and the amount, right? And so that's why we leverage the indexed, okay? Okay, and so that's it. That's the extent. That's the extent of working and mastering events. Now it's just a question of hooking it all up, seeing it in action, and we're going to do that in the course. So this is just a way for you to focus out, think about this out of context, and just get a broader and get a more focused, microscopic version of what we're doing. Now we get back to the course, go back to the events in case you had confusion, and hopefully this will help. I'm going to leave this resource for you and the code, so if you didn't code along, you have access to this resource as well. All right, that's it. I hope you found this helpful. And all right, let's get back to decentralizing some fun stuff together. Okay, see you there.
Okay, so we have the transfer function set up, but we also want to have the transfer from. Now, what's the difference between transfer and transfer from? Well, transfer from, essentially what that allows for the tokenomics of our smart contract here for this mock tether token is that it allows for third parties to run transactions. And then with the approval, because we're going to write the approve event as well. So with the approval, then these third parties can then do events such as pay for gas fees, and do transfers on behalf. So you've probably seen that on dApps in the past. And so let's go ahead and write the functionality out for our mock tether token. So what we want to do is make another function and call it transfer from. And we're going to do another address, but this time it's going to be from. We're also going to have our address too, and we're going to have a uint 256, which will be our value. Oh, and you know what? In our function transfer, let's also make the integers here 256. And we're going to do a public returns, again, bool success. Okay, and what can we add here? Well, we know that we want to do the same thing. We want to do the same thing here with our balance. So we can say balance when we add, what we're sending it to, we want to add to the value. What about from? We can do the same thing here. And for from, we don't want to be adding, right? We want to be subtracting the value. Balance, transfer from, okay? And we want to end it the same way here, right? We want to emit this transfer using from, to, and our value. And wait, hold on. There is a mistake in the transfer function that I just noticed. Can you spot it? If not, anyway, it's just an auto mistake because I just auto-filled in emit transfer, so it brought in the from. But really, when we're transferring here, we don't have a from. Our from value for our emit transfer technically is actually the message sender, right? The person currently with the contract, so message sender. But here we are actually using the from address. Okay, so now for third parties, we have a balance to where we can add to the third parties the balance from, which is going to take away, and we emit the transfer. But we don't want this to just happen willy-nilly, right? We don't want our investors or customers to feel like, oh man, wait, did that just happen? Why couldn't I have had the option to approve? They need to physically go through that additional security measure. That's why we started writing out our approve event as well. So what we want to do is create an allowance in order to execute this as well and add this to our transfer. And in order to do that, we're going to create another mapping. So I'm just copying our mapping over here, and we're going to make it public. We're going to call it allowance. Okay. And what we're actually going to do is we're going to map into our mapping. So we're actually going to map into our mapping like this. Okay, this can look a little confusing, but really essentially what we're doing here is we just have a mapping that we're sending an address to, and then of those addresses, we're doing the same thing. We're mapping and we're providing a key store value for each address. And this is all going to be set to our allowance. All right. So that's how we're going to be able to keep track with iterations for our allowance. So now that we have our allowance mapping set up, let's go ahead and add the allowance functionality. Oops. And here, let me fix this. All right. So we're going to bring in the allowance in our function transfer from. We're going to say allowance. And what's the allowance going to be? It's going to be message.sender. And it's going to be from minus equals underscore the value. And we don't need these comments to be out so much like that. Here, let's actually just bring them in. So what does this all mean? Well, remember, it's our allowance. Well, our allowance comes from the message sender, and the address is going to be equal to the allowance of the message sender from minus the value. The caller's allowance from sender is reduced from the amount, okay? And finally, when we're doing these third-party transactions, we should also have some requirements set in. So the first requirement we can add here is that the value is going to be greater or equal to the balance of the address from the address that you're sending. So this way, this ensures that when we're doing these transfer froms, the value will always be greater than or equal to whatever the balance is happening. So we don't want it to ever be lower. We don't want it to ever be lower than that. And we want to do something similar for the allowance as well, right? So I'm just going to copy paste this, and we're going to do it for the value of the allowance from the message sender, right? And I made another mistake. That's okay. Coding is all about making mistakes, but then correcting them, figuring out what they are. So it's not that we don't want to require that the value would be greater than or equal to the balance of, because that would pretty much just stop everything from happening. We want it to be less than or equal to the balance of. And same thing here. We want also same thing with the allowance. We want to check to see that the value that we have here is less than or equal to the value of the balance from the address. Okay, and that's it for our transfer from, and that's it for the transfer from function. It's a little bit more. There's a little bit more logic, but it's not really so bad, right? When we're doing the transfer from, we just use the balance of the address to where it's going. Is going to be whatever that balance already is, plus the value that is being transferred from that. And we do the same thing for from, except we don't want to be adding. In that case, we want to be subtracting. Then we have an allowance here so that we check the message sender with the address, and we subtract from what the value is to that. Okay. And then finally, we make the requirements so that the value is less than or equal the balance of the address where it's going from where it's being transferred from, sorry, and as well as checking for the allowance with the current contract. We're almost there. Let's go ahead and write the final functionality for another layer of security and add this to the smart contract as well. And what we're going to do first actually is I'm going to change this event from approve. We're going to call it approval. Okay. Approval. So the tense makes a little bit more sense. And we're going to write in a function over here. So we're going to write function approve here. And we're going to take two arguments here. We're going to take a spender to be approved and a value in the arguments. And we can hopefully you know now that this would be uint. And spender is going to be our address. And again, it's going to be the same thing. Public returns bool success. Okay. And sorry, it's returns. All right. So how do we write the approve function here? Well, we want to go back to our mapping with our allowance. And what we want to do is we want to say our allowance, and we'll set it to the message sender. All right. And we're going to check for the spender, and we're going to set that, and we're going to set this equal to the value. Okay, so the allowance essentially for our mapping, what we're looking for here when we're proving is that the person who is currently connecting to the contract, okay, towards the spender is going to be equal to the value, and this needs to be approved. So we're going to check through, we're going to map through this and make sure that it's equal to the value before we can approve. Okay, that's our approve function for our message sender. And that's coming from the spender, right? Because the message sender is the person that we want to be approving. Okay, and again, just like we did with our transfers, we want to emit the event. So we're going to emit the approval event this time. Okay, and what are we going to be emitting here? Well, msg.sender, we have our spender, and we have the value. Is that it? Well, remember public returns, so we want to return this function. Okay, and awesome. That's it. That's it. Looks like we actually have coded together the smart contract for a mock tether. Tether together. There's a pun there. I don't know what it is. So excellent work coming along and going through these steps. Now, if a lot of this isn't making sense, it's harder to see it. And if there's anything that you don't understand or you're not sure of, then I always encourage you to just stop, rewatch the video, or go back to the sections that are more relevant and specific for what we're doing. So we're just basically building a contract, and we do this in Solidity in the most static way possible by setting up an object as a contract, setting it to the tether, so to the name, then running out our metadata and the important information. So we have our name, symbol, we set the amount, we set up our decimal places because we're using integers, remember, in Solidity, and because in Solidity we can't work with dots and fractions, so that's why we do this decimal thing. Then we have our transfer event so that we can do transfers. We set up in our transfer event addresses. We want the from address, we want the to address, and we're going to be using the integer values we're going to set up our value. We do the same thing, very similar for our approval, except for instead of it being from and to, we have an owner and a spender, right? Okay, then we create some key store values with our balance. So we can keep track of the balance, so we can keep track of the balance of each address, and we can do the same thing for the allowance as well, which is checking through the address of each one and then mapping what that is. And I accidentally did something weird there. Okay, we set up a constructor over here where we set the balance of, and then we have our transfer function here. Our transfer function takes an address to where it's being transferred and just the value of what the integer is. Because remember, that's all we're doing with this is transferring. When we transfer, what we want to do is we want to subtract we subtract what the balance is of the current address, the message sender, minus what the value is that we are transferring, okay, which we're going to see when we start using the transfer function. The transfer of balance of, same thing, only now we're adding it because this is the address to, so we want to be giving them the value, not taking away. Otherwise, whoever's on the other side is not going to be happy. Then finally we call the emit transfer. So we make the event happen with the message sender, to, and value, and we return it true because this is taking the Boolean success of it needing to be true. This is a Bool success, and so we have to return this function as true. Transfer from, very similar, except for it's third party, and we need to have this allowance, and the allowance is checking the address from for the message sender, and that's got to be equal to that minus the value, okay? And then finally, we have our approve function, which that the spender addresses are equal to the value, and then we return that as true as well. And that, in a nutshell, is our Solidity contract with full functionality for approval, for transferring, and for transfer from third-party transfers as well. Very awesome coming this far. I know this is tedious, and I know we didn't get to stop that often. But hopefully the examples and you taking your time to write things out yourself and me stopping and going over each part has helped you to get a better understanding of the smart contract process right now. Once we start building out the digital bank, get this contract to interact with the bank, and we're going to play with that on our Truffle console as well. So keep it up. A lot of good things coming. I'll see you in the next video. So now that we have our Tether contract set up, let's go ahead and write our reward token contract as well. Because remember, with our application, what we want to do is yield farming. So you can come onto the application and you can take some Tether and you can deposit it into our bank, and then you get rewarded with our reward token in exchange, okay? So how do we do that? Well, we need to have a reward token, right? We've got the Tether token, and so we need to have the reward token, and then we also need to have the digital bank contract. These all require their own smart contracts. So we've got our migrations contract in Tether, but we don't have our bank contract, and we don't have our reward token contracts. So let's go back to our contracts folder here and make a new folder, and let's call it rwd.sol. So rewards.sol. Okay. Oh, sorry, not a folder. It's got to be a file. My bad. I don't know what a Solidity folder would do. Not very much. So rwd.sol here. Okay. Now, our reward token is going to be very, very similar to our Tether token contract, all right? We're not going to do any crazy other tokenomics. In fact, the functionality is going to be exactly the same. So instead of sitting and retyping everything and going through it again, because you could always just go back to the last video to do that, let's just go ahead and copy this, paste it in here. So I'm copying our Tether contract into our WD, and we're just going to change the name. Gotta love copy paste. So the contract's going to be called RWD, and string public name here, we're going to change this to reward token. And we'll just change the symbol to RWD. And we'll leave the same supply and decimals, and we'll leave everything else pretty much exactly the same. Save that, and there you go. And that's it. So now we actually have our second contract done, a lot faster than the first one around. And that is the beauty of templates. Okay, so we've got our reward contract set up. We've got our Tether contract set up. Let's write the basic setup for our digital bank and then deploy all this together to see that everything migrates to the database, to the blockchain database correctly, and we're good to go. So we're going to make another file in our contracts, and this time we're going to call it decentral bank, all right, .sol. This is going to be our digital bank. So decentral bank. All right. And we're going to do the same thing. So I'm just going to go back to Tether, or maybe I'll go into migrations. I'll just copy the code from migrations, paste it into decentral bank. And we're going to call this contract decentral bank. All right. Address public owner is cool. We'll keep that. And we'll get rid of all this for now. We don't need any of that. And what we can do for now is we could add a name. So we're just going to do string public, and it's going to be, and how do we make a name? Well, we just create the variable as a string called name, and then we set it to the name we want, which is going to be decentral bank. Okay. And that's it. Okay, we created another contract. Look at us. We're contract ninjas, left, right, and center. All right. Maybe we're getting too excited here. But really, this is great. But really, we are making progress. So we have our Tether contract, RWD, and our decentral bank, which is going to be taking both our reward tokens and our Tether tokens and interacting, depositing, withdrawing, staking, all that good stuff. So let's go ahead now. Let's go ahead and deploy this. So I'm going to go back into our migrations to our deploy contracts. And what we're going to do first is and what we need to do first is, what do you think? Well, we need to bring in the contracts, right? So just how we do it up here. I don't know why that's on line 2. Oops. We're going to create more variables. We're going to do a variable for RWD. And we're going to create a variable for decentral bank. And we're just going to set these to require our smart contract information. And here, let's actually add some comments. So right now, we are exporting and deploying the Tether contract. So deploy mock Tether contract. So I'm adding some comments here, right? And we can do the same thing for our other contracts. So let's do that. So let's deploy mock Tether. So let's deploy and here we can just rename it to RWD, and then we want this one as well, our decentral bank. And yeah, I know they're not interacting yet, but this is just so that we can get a start on this and set it up on this. And also I want to make sure that we updated our Tether contract, so I wanted to see that everything uploads correctly and that it's all up on the blockchain and our functionality is all right. So we're going to do a deeper dive into the functionality once we just implement a few more a few more key features for the decentral bank contract, but just to see that it works. And it's uploading. Okay, and so this one will be decentral bank. Hit save. All right, so let's go to our console and make sure we're in the Truffle development. I'm just going to go over here, and I'm going to run a Truffle migrate -- reset. And we use the flag -- reset because we are updating effectively. So we're resetting the addresses to new addresses. We're not actually updating what's going on within the contracts that are already up. We're providing new addresses and putting those up onto the blockchain. And oh no, it looks like we've made a mistake. And let's see what the mistake is. It's okay to make mistakes. In fact, it's important for me to leave these mistakes on to show you that this is part of the process. This happens all the time. Did you intend to add public? We see that in our reward Solidity contract, we did not add public. In our constructor, as well as in our Tether contract. So let's take a look. And yeah, this should be public. As we can see here in my tether.solidity in the Tether contract, I did not make this public, so we would not have access to it. So we want to make this public. So that's a mistake. And did I do that here as well? Yes, because I copy pasted. That's the folly of copy paste right there, right there. And here we don't actually have a constructor yet, but when we do, we will want to make it public. Okay, so let's go back and try it again. I'm going to run the migrate reset once again. And fingers crossed it works this time. Whoa, and all right, look at this. This is looking good. This is looking good. It looks like we have successfully compiled and migrated our contracts, and we can see we have our transaction hashes, we have our contract addresses all set up now. We've got contract addresses for RWD, for Tether, and if we look here, actually, if you look at the Tether contract address, and we can see as well that some gas was used, and we have a new balance. Okay, so let's go into our Truffle console and run a couple tests to see that things are looking good. So we're going to go into Truffle console by typing Truffle console and enter. And from the Truffle console, let's just see if we could grab some more names. So we know that we have Tether, right? Because we've done this before. Let me see. So if I do Tether equals await, tether.deployed, and we call Tether, we see that we get Tether here. If I run tether.address, we see the address here. So, okay, so this is good. It means that Tether is still up and working. This should also now work for our reward token as well, remember, because we created the reward token as well. So if I do RWD, it's going to equal RWD. Whoop, we have to wait for it. RWD.deployed. And we run RWD or RWD.address. We see another address. If I call the name, we see reward token. Awesome. And finally, you can go ahead and run a test to see that the Decentralized bank is running as well. But this is great. It looks like everything is up and deployed. The migrations are happening successfully, and we have already built out our smart contracts. This has been actually a lot of setup and legwork to get things running, but now we can start developing the digital bank functionality for our users, our customers, our investors. So very exciting. So things are about to get heated up. I hope you're as excited as I am. Let's keep up the good work, and I'll see you in the next video. Bye. All right, so inside our digital bank, what we want to be able to do is we want to have access to the Tether tokens and our reward tokens, and we basically want to be able to keep track of these and then be able to issue tokens, reward tokens, and keep track of the state, take the deposits, be able to accept deposits and withdrawals. So in order to make this work, we actually need to bring the contract information or the contracts themselves of these other tokens, the Tether token and the reward contract, into our Decentralized bank. So we can actually do that by as simple as importing them. Very similar with React. You can do import, import RWD, and now what we want to do is we can build a constructor in here and set up variables. So it's kind of similar to what we were doing when we were building our constructors in our Tether Solidity and our reward Solidity. We have our constructors here where, if you remember in the Tether one, they're the same thing. Essentially, we set the total supply to the balance of whatever the person that's using for the contract at that moment connecting to that. We made that equal to the total supply. So we use a constructor to do this. So we're using a constructor here to set up our interactions with the Tether token and the reward token. So what we can do is we go into our contract, create a constructor. All right, and this time we're going to make it public. Remember, that gives it visibility. We don't want to run into that error again. Okay. And what is our constructor going to take exactly as arguments? Well, it can take the reward token, and we can do an underscore, RWD, and it can take our Tether token. But remember, this is in JavaScript, so we need to set. We have to statically type. We have to statically set these, and it's not going to be a string or a integer. We can actually set these to the contracts themselves. So this can be RWD, and this could be Tether and Solidity. And let's do the same thing except for in the contract overall as well. So let's go ahead and set tether public to tether, and RWD public to RWD, if I can spell public. And finally, within our constructor, we can do the same thing, where we can actually say RWD is equal to RWD, and tether will be equal to underscore. Now, this may look a little redundant, but hopefully you see that it's actually not. That what we're actually doing here, it's important for wiring the smart contracts to each other and doing it using the Solidity language. Because effectively here, what we have now is we've set our arguments to the contract specifically. So our instances here happen with reward and tether. And then we also have declared our public, we've also declared our public tethers variables to tether and another one to reward as the contracts themselves as well. And hopefully that's making sense. If it's not making sense yet, it's okay. We're going to go to our deploy contract now and set it up so they can interact with each other. And that should actually provide you some more clarity and insight to how these contracts are going to be interacting. So let's go back here to our deploy contracts and let's look at the function here that deploys. And let's make some modifications so that what we want to do effectively is we want to move all of our reward tokens into the decentral bank. We want our digital bank to have all of these reward tokens. And then the other thing we want to be able to do is we want to be able to transfer tether tokens, our mock tether tokens, into our investor from our decentral bank. We want to give them 100 tokens to start, okay? Well, it's actually not so bad at all. The first thing we want to do, let's add some additional arguments to our function. So we're going to add a network and accounts, okay? Now, first off, let's focus on transferring all of our reward tokens to the reward contract over here. Reward tokens to the bank. So what we want to do first is let's go ahead and make a variable constant reward. Equals await. And here we can do reward dot deployed. So we're going to wait to receive our contract over here for reward. Receive. And we're going to await to make sure it's deployed before we run this, right? Okay, so then underneath here, let's go ahead and let's write a comment here, transfer all RWD tokens to the central bank. And how are we going to actually transfer this? Well, remember, we now have access to our transfer function. And what is our RWD transfer function? Well, if we go back to it and we look back at transfer, we see that our transfer function is right here, and it requires 2 arguments that we created, an address and a value. And what would be that value? Well, the amount, right? But we call it value, okay? Now, if I go back over here, how should we write this contract? How should we write the transfer? How do you think we should write it? Well, we can do rwd.transfer, and then we can add our execution. So we want to transfer 1 million, right? So we want to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I think that's correct. And remember, what was the first? Was the address, right? And which address do we want to be transferring it to? Well, we want it to be transferring to Decentral Bank. Oops, if I can spell it. Decentral Bank dot address. Now, will this work? Is this good enough? Or did you catch an error? If you caught an error, excellent. Not, don't worry about it. But yeah, if you said, hey, wait a minute, we have to make sure that we await for this before it happens, because otherwise it's just gonna go with or without the information. So we're going to await for the reward transfer to happen first before we proceed to anything else. Okay, so now we have the functionality to transfer all of our RWD tokens to the central bank. Now, what's the other aspect? What's the second half of what we want to do here? Well, we also want to distribute 100 tokens to our investor. So when our investor comes on, they get 100 tokens automatically when they come on the app, okay? and when I say 100 tokens, I mean, of course, 100 Tether tokens, so the USDT. And how would we write the code for this? Well, it's Tether, so we're going to need to have a variable for Tether, which we don't have. So we're going to do the same thing here. Constant Tether is going to equal await Tether dot deployed. Okay, and then we may as well also do one for Decentralized Bank here. So I'm going to do this over here. Constant equals await Decentralized Bank dot deployed. Oops. All right. Okay, so now that we have our Tether variable over here, what we can do is we can say await. And what are we doing? What are we awaiting? It's another transfer, right? So tether.transfer. And this time we are going to be transferring to the account of the investor. Like if you see over here, we transfer our tokens to the Decentralized Bank. But over here, what we want is we actually want to transfer to the investor account. And if we go back to Ganesh, we're going to see that we have all these accounts here. We got 10 free accounts, right, that we're using. Now, for the purposes of this app, we've noted that our first address is going to be the address, our address, right? It's the owner address of our digital bank. It's the digital bank address, okay? So for all intents and purposes, this is our address. Now, we're going to allocate the second address. We're going to make the second address the address of the investor by default. So that's going to really help us out so that we don't have to develop an entire backend, because this isn't a backend, because this isn't a course on backend applications. And already blockchain is a type of backend. If you think about it, it's a database. But for all intents and purposes, without creating sign-ins and using Firebase or whatever we need to do, and Postman or Firebase, we're just going to say that the second address is going to be the address of the user, of the customer, the investor. So this address here is going to be the address of the customer, and this is going to be our address. So knowing that, so bearing that in mind, well, we can actually write account. And here we can select the account, and we want the second account, so we're going to write 1, right? Because in computer language, everything starts at 0 is 1, right? This is 1, 2, 3, 4, etc. Now, if you don't know that, very basic. Welcome to computer programming, something that you are going to get used to, I promise. Just takes a little bit of time. You'll get there. With iteration and iterating through arrays, objects, and we're going to see time and time again how 0 starts at 1. Okay, and then for the second argument, it's the amount again, and this time we don't want to give them 1,000,000, so we just want to give them 100, so that's going to be this amount minus 6 zeros, right? 1, 2, 3, 4, 5, 6, because remember, 18 decimal places is going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops, 13, 14, 15, 16. Okay, wait, I made a mistake. I see that I've made a mistake here. Let me see how many decimal places this has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so this would just be 1. We need to add the 6 to get to 1,000,000, because remember, we have a total supply of 1,000,000 in our reward tokens, so I'm going to add 6. 5, 6. Glad I caught that mistake. And then I'm going to copy this and replace it, and now remove 6. 2, 3, 4, 5, 6, and now I'm going to count. I should have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. Okay. So remember, this is 100, and this is 1,000,000. And if you are still confused about that, just go back to when we were building out our Tether contract, where we did an explanation about how this works with the decimals and the total supply. Oh, and I just noticed another mistake with my camel case here. This should be lowercase Decentralized Bank, and this should be uppercase. Like that. All right, now let's save this, and whoops, I made one more error. Wow, really on a roll with my mistakes. This should actually be, can you spot what the error is? And I'm highlighting it. Account, so my third argument should be accounts, not account. We're selecting the second account like that. Okay, so now this should be good. Anyway, we're going to find out because in the next video, we're going to migrate and we're going to deploy our smart contracts, update, and see if we can actually access some of this interaction, some of the interactive features that we are starting to develop together. Hold on to your coding hats. Things are going to get heated up. Great work. See you in the next. So now that we have essentially our contracts all up and ready to go, let's go ahead and use the Truffle console to test to see that we can successfully deploy these contracts, that we can transfer the tokens to the Decentralized bank over here, and everything is, is good to go. There's not too many, there's no mistakes. Well, not too many. Hopefully there's no mistakes. And let's go ahead and go through all that and review what we've done through this process of setting everything up. Okay, so we're going to go back in the terminal. I'm going to go ahead and make this a bit bigger so you can see. All right, hopefully that's better. Okay, so the first thing we want to do is load up the Truffle console. Cue the elevator music. Do, 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 do. Oh, and we've got some sort of error over here. Cannot connect to your Ethereum client with the following parameters: hosts 127, port 7545. Okay, so I think it's actually because if you noticed, I closed my Ganache, and Ganache is compiling. All right, and here we go. I got a nice fresh slate. So I've got my addresses here. We notice that we have the same port opened up, and we have the same network and the network ID. Great. Okay, so, and this is, if you load up a new instance of Ganache, it still should run on your Truffle console because we're always hooking up to the RPC server, and it's just going to fetch the new address information because this is an array of accounts, right? And that's what it will be looking for. And so we can actually further clarify this point if we go back to terminal and I rerun Truffle console. Okay, so now our Truffle development environment is loaded. Looks like we're good to go. It's hooked up to our Ganache. So let's go ahead and run some tests to see that we have successfully deployed our contracts and the new integrations of interacting with them. So what we're going to do is we're going to create an accounts over here, and we're going to set our accounts to web3.eth.getAccounts like this. And we are going to await. Because we need this to run first, so we need JavaScript to wait for us to get the accounts before we can actually get the accounts. Okay, and let's process that. Okay, and so just in case you're still confused about this, essentially we're running Web3, which is accessing the Ganache, and we are getting it from ETH to get our Ganache accounts like this. Okay, and we have 10 accounts over here. So this is an array, meaning that now if I want to verify that our accounts are the correct ones and they're up and loaded, I can just put in accounts like this, create an array, and let's say we want the owner address, so the first account, and there you go. So we see this account ending in the E204FC. Sorry, it's the morning time over here. E204FC, and if I check on Ganache, we see the first account over here is E204FC, right? 100 ETH. Woohoo, we're rich. But, don't get too excited. It's not real ETH, right? This is just tests. And here's another thing. Be careful, just a disclaimer here. Be careful with these accounts. This is for fake ETH transactions only. Don't use these accounts. Be very safe, especially with showing your key over here. This is your private key. You don't want to do that. Show that to other people. So this is just for test environments. And we're doing this for our purposes of learning together. Okay. All right. So we see that we have the account, and we can also show that here we have accounts. We can grab other accounts. if I can spell it, not account, accounts, not, there we go, there's another account. Okay, so we have this account, let's say the first account, right? And we know that there's 100 ETH, but we know that because we are clicking on Ganache. Let's say we wanted to verify the balance of using the smart contracts and the functions that we built instead of clicking on Ganache, all right? Because we want it to be working in our code, of course. So how would we do that? Well, what we could do is we can set balance over here, and we can run another await, and we can say, wait, actually, hold on. Before we even do this, we should also grab the smart contract for our tether, right? So let's go ahead and do that and do it like we did it last time. If you remember, we're going to do tether await. I'm going to say tether.deployed. And now if we call tether, we see that tether is there. And we know it's tether. We can verify this. Okay, so we have the right address, but I believe we actually did not compile we forgot to compile and migrate. So why don't we run a compile and make sure that we didn't make any mistakes with our contract. So let's do Truffle compile. And I forgot to actually migrate as well. Please forgive me, it's Monday morning. So let's go back to another instance in your console and run Truffle compile. This is outside of the Truffle console. Okay, so we see we actually have an error over here. So the error is a parsing error, project /src /contracts not found. And this is in the Decentralized bank Solidity contract. So let's take a look actually what I did here. Okay, so I just noticed my error. Do you notice it too? Well, we can't just import RWD. We have to specify the type. So this is .sol. This should be .sol as well. Okay, so that's this is one of these pretty little big mistakes. It's a little mistake, but it also has a big consequence. All right, so let's go back to the terminal and run the Truffle compile. See that we have no mistakes. I can't believe I said that we're going to do this, and then we didn't even do it. All right, let's go ahead and do it now. Okay, so it looks like we've successfully compiled. Okay, so we fixed that mistake. Now let's run a migrate for our contracts, and we're going to use the reset flag to update the addresses. So let's go ahead and do that. Okay, so it looks like we're getting another error over here. And we see that it's a deployment failed over the Decentralized bank contract. But it looks like the other contracts worked all right. So let's go ahead one more time and take a look again at the Decentralized contract. Okay, so there's another mistake that I made. Well, you see in my Decentralized bank, you see under the Decentralized bank deploy contract over here, I created a variable Decentralized bank. And I set that to Decentralized bank deployed. So I wanted to wait for it to deploy first. And then we run this transfer, right? And we wait for this transfer to happen as well. And we want to transfer the 1,000,000 tokens to our Decentralized bank address, right? And these are the 1,000,000 reward tokens. But when I'm transferring it, I'm not actually transferring it to our variable that's waited for the Decentralized bank to deploy, but to the actual Decentralized bank address. And since this isn't awaiting, it's not actually probably getting the address correctly because of the synchronous nature of JavaScript. Therefore, it's not working. I mean, that's what I see. So the mistake here, all of that can just be translated into, oh, this should have been lowercase, essentially. So hopefully that makes sense. If not, listen, I just made an error here. I didn't set the variable up correctly. So I'm going to save that. And the final thing that we can't forget to do here is we want to add the reward.address. This is in our deploy contracts. And the tether.address. So first we're going to run Truffle compile. Okay, so let's do Truffle migrate. -- reset. All right, so looks like it works now. Awesome. So we see that we have our contracts here. We even had some gas fee being used. So if we check in Ganache, we're going to see that our first account took a balance there. They took about 0.11 ETH. So it's not chump change. And I'm just happy that it works, that we fixed the problem over there. Okay. So now we're going to go back to the console. What we want to do is actually restart the console. So exit the console. You can exit with .exit and then just go back into it. So let's restart. We're just resetting it. Truffle console. We're back in the development. So let's give this another shot. Let's go tether is going to equal await tether.deployed. And now if we run tether.name, okay, it looks like it's working now. Phew. So we got the mock tether token. Excellent. So now we've set up our tether. So if you remember, we want to grab our account information, and we do that using Web3, right? So remember, we set up accounts to equal Web3. We want it in ETH, and then we run the get accounts. Okay, function. Okay, and there are all of our accounts. We can see the 10 accounts right there lined up. These are the same accounts that we have in Ganache. And so we receive the accounts. What we want to do, of course, is here we can't forget to put await, so we can fetch them that way one at a time using a promise. All right, so now if we grab the first account, we'll actually get the account. What I did before is I didn't put the await, and instead it just ran through quickly and just returned what all the accounts were. When I ran it like this, we see that it's not even necessarily going to work. But when we run the await accounts, now we can grab any account. So if I grab the second account, it ends in A47B7. And if I check on Ganache, A47B7. Okay, excellent. So now we have the account. We're using async await. And we also see that our tether is now working. So the next thing we need to do is let's check out the balance and see if we can grab the balance, like we said, not through Ganache, but through the code that we built by interacting on the blockchain. So we're going to set up a balance over here, and let's do it with tether. So we're going to say await tether. And what are we going to put after tether, do you think? Well, we're going to use our tether smart contract, and we're going to use a function. And we could actually use the balance of function that we built, and I'll show you how that works after. And then which balance of do we want? Well, we want to grab it from our accounts, right? And let's say we want to grab the account of the investor. So that would be the second account, if you remember, for what we are building here. So then we just type in accounts and we put the array to 1, right? Let's hit enter. We get this undefined returned. But now if I type in balance, you see that we're getting a BN. And if I turn the balance, oops, and I have to remember to call it to string. All right, there we go. So now we see the balance of the account. Okay, amazing. So we're actually interacting with the blockchain now, and we're able to receive the balance of, but I would rather see this number as a million than as one with 18 zeros, right? Because remember, this is supposed to be a million ETH. We're supposed to have a million tokens. So what we can actually do is we can leverage Way to match our tether tokenomics, because Ethereum actually has 18 decimals as well. And we can use Way here, and basically Way, if you remember, we discussed it, one Way is equal to 1 over to 18, whatever that would be, 18 ETH, right? So, or 1 ETH is equal to 118 blah 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 Way, right? So knowing that, we can actually run a conversion and run the same conversion using Way to get our rewards, because they also have an 18 to 18 ratio. So it's a 1-to-1 ratio. And hopefully that makes a bit more sense now. It makes a bit more sense now since we've gone over it a couple times, but if not, you can just go back to where we were building out the smart contract and check out the explanation again. We're going to have a converted balance here. So we're going to convert balance, grab it from Web3, we'll use the utilities, and we can use the function from way. Okay, and then we can, what would we put in the input here? What do you think we should be putting in here? Well, we want to convert this, and what is this? Well, this is balance, right? So we would write balance. And there we go, 100, perfect. So now we've converted it to 100, and we're going to use this as, and the other reason why I wanted to show you this now is that this is going to be an important helper function when we're building out our code, because we don't want to constantly be rewriting this over and over again. So I just wanted to show you this conversion and the formatting of it and the importance of it, especially when you're working with Ethereum and Way, or you're working with cryptocurrencies that generally have a lot of decimal places running next to them, right? And so we've seen from Way, but there's also to Way as well. So these are essentially just functions from Web3 from their utilities that we can just call to convert. It makes our life easier. So for example, let's say that we had 15 Way and we wanted to convert it. Sorry, let's say we had 15 Ethereum and we want to convert this to Way. How would we go about doing that? Well, we can just leverage these Web3 utilities. So we could say web3.utils.toWay. And here we can actually express the amount. So we can say 15 and comma, and then we want this in Ether. Let's run this. Oh, and sorry, this should be passed as a string as well. And here we go. So now we've got 15 converted to Way. We've got the 15 with the 18 decimals after. Oh, let's just close that. Okay, awesome. So this really seems to all be checking out. We're able to grab the balance. We're able to see that everything's been deployed correctly. All of our setup is done. It's really time for us to now build out the digital bank. And if some of this stuff is still a little bit unclear, like you're wondering, for example, well, what is this tether.balance of accounts? Before we end this video, let's just go back in the code and connect these dots for you one last time. So when we were fetching this tether.balance of accounts, right? The tether, if you remember, comes from our deploying of our tether contract, right? And then essentially the accounts come from the Ethereum account from our Ganache, right? Over here. And then finally, our balance comes from the balance of function that we wrote. So if we go back in the code, we can see already here in the deployed contracts that we have our tether from artifacts required tether, and that we deploy our tether over here. So we get it. We await for the smart contract to be deployed. Right here is the tether. And if we scroll down on tether, we see that balance of was mapped out when we wrote it, if you remember. So we did a mapping. And we set up our balance to be the total supply of the person that's connecting with the contract. Okay, so that's where our balance of comes from over here. 1 million tokens, right? And that's why when we fetch the balance and we turn it and we convert it to a string, we see that the balance is 100. And you can say, well, hold on. 100, isn't it supposed to be a million? And I can say, yes, it's supposed to be a million. 1 million is the total supply, but remember that we're getting it from the first account, and the first account is supposed to be the account of the investor. And if you remember, what we did in our code is where we deploy our contracts, we automatically, the first thing that we do when these come up, the automatic first response in the deployment is to actually transfer 100 mock tokens to the account, the first account, which is the user, the customer, the investor. So they get that 100. And that's why we see 100. And that's why we see 100 in the accounts. So that was just a step-by-step rundown of what we did and why exactly we did each thing. So hopefully that's clear now. So hopefully that's pretty clear now. If not, just feel free to go through it. It's okay if you're totally new to this, and it's okay if you're totally new to this, that it could take some time. If you're getting it, that's awesome. Our setup is working. When you're ready, whenever you're ready, let's move on to the next video where we're going to actually start to build out our decentral bank together and start running some proper tests, just like you would see in the real world with assertions and using and using Mocha. Sorry, not Mock. Using the Mocha framework. Okay, awesome. Great work. Okay, see you in the next video. Bye.